Hello everybody, this is Arunava Sarkar. Today I am going to teach you benzoin condensation reaction. It's one of the characteristic reactions, especially for the aromatic aldehydes. Let's see what happens here. We have an aromatic aldehyde which is benzaldehyde. We can figure it out as step 1 of the whole reaction process. It is going to react with Cn minus. We understand what happens there. This polarity of CO bond is that carbon will get partial positive charge and O will get partial negative charge. Why? Because of the electronegativity difference between both of them. So this Cn minus takes the advantage of this positive charge and as a nucleophile it attacks on the carbon atom, which will give you an alkoxide type of product. Now, the most interesting one is step 2. You know what happens here? This Cn minus creates a minus I effect over here. Another effect is also there, that is minus R effect. But at the first, what the minus I effect is doing, it's making this hydrogen sufficiently positive charged. And you know what happened? A very peculiar thing happens here, which is this H plus comes and attack on this O minus. That gives you a product like this. What is the utility of getting this product? You see, this can make a resonance stabilization. One of the most important facts why Cn minus is a unique reagent in case of benzoin condensation. Step 3. This pH this carbon ion is going to react with another aldehyde, that is another benzaldehyde. And one of the most important thing here, can you see that what was the polarity here? This was getting a del plus, that is a partial positive charge, and this was getting a partial negative charge. But you see, at this carbon, initially there was a positive charge, but after this reaction happens here, this attack happens here, this carbon gets a negative charge, that is the carbon ion is being produced. So polarity is getting reversed. So it is known as polarity reversal. This is also known as Ampolang. Ampolang is a German word which means polarity reversal. So after this will again makes a polarity like this. So C will get a plus charge. So this minus will come and attack here. It is going to give you pH, C, OH here, Cn here. This C is now connected with this C, giving you O minus, H, and then pH. What happens after this? This minus takes this H. So we can take it as a step 4. We can take it as a step 4. And let's see what happens in step 4. That is, this O minus withdraws this H. Why? We will understand that. It's because this minus now comes back here to form a more thermodynamically stable CO bond and thus allowing this Cn minus to go out. So what you got here is, it is a functional group here, ketone, it is alpha, so you have got an alpha hydroxy ketone. And the most important question that can be asked in any competitive examination, that why Cn minus is a good choice here. Number 1, it's a beautiful nucleophile. At the first step it was working as a nucleophile. It is a beautiful leaving group. It is definitely a very good leaving group, for which this Cn minus is easily leaving from here. And the another one was that Cn minus was helping the carbon ion to get stabilized by the resonance effect. So this is what we have learnt this time that the aromatic aldehyde like benzaldehyde got condensed, and by the condensation, that is the connection of two molecules, it gave you a product which is alpha hydroxy ketone. Thank you very much.